So this is a general linear programming model for transportation problem. I just want you to learn about the notation of linear programming. Xij, as I said, I means source, j means destination, and number of units shipped from source I to destination j. How many shipments do we need to make? That's going to be represented by Xij. Cij is the cost of 1 unit from source I to destination j. Say Cleveland to Philadelphia, right? That's Cij, and that's say $30. However, Cleveland to Boston is say $50. So that's we are using I as the destination source city and j as a destination city. And Si means supply at source I, right? How many inventories do we have? How many things that we have stored in our warehouse that's available in Si? And Dj is demand at destination. In Philadelphia we have 1,000 customers or 500 customers or 500 bikes are required in Philadelphia. That's going to be determined here and notated by dj. And the function can be explained as minimize cost sigma j 1 to n, and then another sigma I equals 1 to m Cij times Xij. That's minimize cost, and if you simply simplify everything, this is going to be it. And one example that we saw was say 5 is the coefficient, the transportation cost from city 1 to city 1. So source city 1 to destination city 1, and that's x11 plus $4 times x12 and so forth is going to be summarized here in this mathematical format. And then we can also add this Xij has to be less than equal to Si, right? So if anything, so j is a destination, right? Destination j, to say there are 5 cities, then j1 to j5. So x1 1, x1 2, x3 1 3, x1 4, x1 5, that has to be less than equal to the supply of source city 1, right? So that's what it means that we just talked about in the previous example. And demand is xi equals 1 to m. So I is fixed and then j is changing, and that's what it means. I think I talked I switched it to j1, so the destination is fixed and the supply is the source is changing, so j1 to n. So j is changing but I is not changing, so that's for supply. And for demand is I is changing but j is not changing because j is the destination and the demand is fixed there, right? So that's how we can summarize things in a general term.